In number 9, we have a missing side that we're looking to find, and we're going to find that missing side by setting up a proportion. And that's what I've got over on the side here. We've got two ratios that we're going to say are equal to one another. And those ratios are going to be made up of side lengths from different triangles. And really there's three triangles I could potentially pull side lengths from. The first one is just the largest triangle itself. But because we've got an altitude that splits it in half, that really creates two other triangles. With this one over here, which we'll call the small triangle, and this one over here, which we'll call the medium-sized triangle. Okay, so three triangles that we could use. We're only going to use two of them because we've got two ratios that we're comparing in a proportion. To determine which triangles we're using, we need to figure out which triangles do we know enough side lengths from. So for example, if I look at the largest triangle, I have this entire side that I know of, 64 and 36 together is going to give me that hypotenuse of 100. And then I also know the short leg of that large triangle, which is listed as x. Okay, so that I've got two sides there. I might be able to use that large triangle. If I look at the the small triangle here, I have two sides of that as well. I've got the hypotenuse, which is x, and the short side, which is 36. But if I look at my medium-sized triangle, I really only know one of those sides, which is the longest leg. Since I've only got one there, I'm probably not going to use that side because I don't have enough information. Okay, so it's going to be the smallest triangle and the largest triangle in this diagram that I'm going to use within my ratios, and I need to know where they're going to go. Okay, so it doesn't matter really where they go as long as I keep it consistent, and to do that I'm going to mark it. So I'm going to say that the smallest triangle is what I'm going to put up here as the numerators, and the large triangle is going to be my denominators. And the two sides that I knew from both of those triangles were the hypotenuse and the, the short side, right? The short leg. Okay, so we'll put that there. Again, you could have switched around the small and large triangle. You could have switched around the hypotenuse and the short leg. You could have put the triangles on the top and the hypotenuse and short legs on the side. It doesn't really matter as long as you keep it consistent. So now it's just a matter of working through here and identifying what those lengths are. So if I'm looking at the small triangle, talking about this thing right here, what's the hypotenuse of that small triangle? Well, it's x, the value that we're looking for. The small triangle's short leg has a length of 36, so it would go in that position. And then I think about the large triangle. The large triangle's hypotenuse is this entire thing, right? 64 and 36, so I'd have to add that together to say it's got a distance of 100. And the short leg of this large triangle is x. So now I've got my proportions set up. It's just a matter of cross-multiplying and dividing in order to solve for that value. So x times x is x squared. That should be the same as 100 times 36, which is 3600. And now to get x by itself, I'm going to take the square root. If I do it on one side, that means I have to do it on the other side as well. So x ends up being a value, a distance of 60.